Here's how to solve percentage yields in time for your summer exams. So I've got a past paper question here. 1,3-dinitrobenzene is a solid at room temperature. A chemist prepares 1,3-dinitrobenzene as outlined below. Step 1. 12.5 cm cubed nitrobenzene, density 1.20 grams per centimetre cube, is refluxed with concentrated nitric acid in the presence of concentrated sulfuric acid acting as a catalyst. Step 2. The mixture is cooled, impure crystals of 1,3-dinitrobenzene appear. Step 3. The impure crystals are purified to obtain pure 1,3-dinitrobenzene. The chemist obtains 15 grams of pure 1,3-dinitrobenzene. B. Determine the percentage yield of 1,3-dinitrobenzene to 3 significant figures. The first thing I do is underline all the important numbers, such as 15 grams, the density of the nitrobenzene, and the volume of it as well. It's also a good idea to highlight the significant figures and then write them towards your answer so you know to use them. What I would do in a situation like this is write down everything you know. So you know the structure of nitrobenzene, just a benzene ring with a nitric group on it. You know the volume from the question, which is 12.5 centimeters cubed. You know the density from the question, which is 1.2 grams per centimeter cubed. And then from this, you can use the equation mass is equal to density times volume. And then if you plug those numbers in, you will get a mass of 15 grams. We can calculate the MR, and we know it's 123 grams per centimetre cubed. I can get this number by doing 6 carbon atoms, so 6 times 12, add 5 times 1, which is 5 hydrogens, and then 14 for the 1 nitrogen, and 2 times 16 for the 2 oxygens. You add them all together and you get 123. Now the next thing we can get from this question is the structure of 1,2-dinitrobenzene, which looks like this. And from the question, we're given the mass of 15 grams. And this time for the MR, you can calculate it yourselves, but it comes to 168 grams per mole. And then using the famous equation of N equals M over molar mass, we get a mole of 0.089285 moles. Now we can use the same equation over here of N equals M over MR, and N is equal to the mass, which we know and worked up here is 15. The MR we also found out of 123, and so this comes to 0.1295 moles. The percentage yield equation is as follows, where percentage yield is equal to moles of product divided by moles of reactant. I would like to mention the desired moles, so desired product and desired reactant. Then you multiply that by 100. So if we put the numbers in, 0.089285 divided by 0.12195 times that by 100 will give us our answer of 73.2 for 3 marks. I hope that helps.